Good morning. We're looking at the 12th lesson of this school year, the 12th lesson of cycle one. What we're going to be focusing on today is what's called linear regression. We're going to use technology to write linear functions that provide reasonable fit to data to estimate solutions and make predictions for real world problems. That sounds like a ton. It's actually quite cool what we're doing today. So today you can look back over this later on, but today ultimately what we're going to do is we're going to identify X and Y variables. We're going to create a table with technology. We're going to type in those values and use technology to find the linear equation. And then finally at the end, we'll predict using that equation. So let's get started with what we're doing today. First, what is a regression line? On this little picture right here, you see a bunch of dots very similar to the bell ringer. These dots here. A regression line is a line that best goes through the middle of as many points as possible. So what is a regression line? The line that best goes through the middle of all the dots. That's what's called a regression line, okay? That's what we're going to create today. So let's start with this first one. Here's what I want you to do. Each one of you take your ID badge and look at graph one, and I want you to, with your ID badge, put it where you think the middle of the dots are and draw your line across, okay? I'm going to give everyone a second to do this. Draw a line that you think best goes through the middle of all these dots. Now that I've given everybody time in class to go ahead and do it, let me show you how I would have done it. What I would have done and said, okay, I think the middle is somewhere right in here. And so using a tool from my software here, I would draw it something like this. I might be a little bit crooked. Let me make my bottom end a little bit lower. Something like that is probably what it should look like. But the word is probably right now. It's not exactly. Today we're going to get to exactly. This would be called a regression line. That's what they call it, regression. That just means the line goes through the middle of the dots as best as possible, okay? Let's go to graph two. Flip your page over. Graph two, try again. I'm going to pause my video. You go ahead and put where you think the line should be. Okay, now I'm going to draw mine. Now, here's the deal. I'm going to draw mine here and say it could be there. But does that actually look like it's through the middle? No, this would actually not be as good. What if I put mine there? What do you think? Is that going through the middle? No, it's not. This would not be best. I need it somewhere in here. Here's a question for you. Which one do you think is easier to have it perfectly in the middle? The graph 2 or graph 1? Which one's easiest to have it more looking like it's through the middle? Graph 2 or graph 1? Which one do you think is easier? 1. Why 1? What makes 1 easier? Perfect, Ariana. We're going to learn about that over the next 2 classes. This one is a lot easier because the points aren't as spread out. But you see how the second one, how they're more spread out? This one would be a little bit harder if we had to do this by hand, which I'm going to show you the calculator in a moment. Okay, how about the next one? Graph 3. Put your line through the middle of this graph. Now I'm looking around. I see a lot of eyeballs, people looking at the person next to them. Make your line go through the middle of this one. I'm kind of laughing to myself because I know what I'm about to tell you. But put your line through the middle. Now I'm watching ID badges. I'm not even hitting pause on this one. Y'all can stop on this one. Because on this one, could you say this is through the middle? Could someone make an argument that that's kind of through the middle? Kind of. Let me use the word kind of. Could you actually make an argument that's kind of in the middle? Could you make an argument that this is kind of through the middle? Is that kind of through the middle of the dots? What about this one? Could I say that this is kind of through the middle of the points? Because it's half and half on each side? What about if I did it this way? Could we make an argument that, what other color do I not use here? Could I say that this is kind of through the middle? Hey, you know why this one doesn't work? Is there any pattern at all to these dots? No, this one has no pattern. So this one, you could have drawn a line, that's fine. But this one, there is no pattern. And so we would have no regression. No pattern, no regression on this one. No pattern equals no regression. So truthfully on this one, I'm okay with if you took a guess because I told you to take a guess. You're just following instructions. But truthfully, this does not have regression. What's the difference? Look at these dots compared to the previous 2 graphs. What did you notice that's different? Did this one have a pattern? Yeah, it was going up and to the right. What about this one? Did it have a pattern? It was going down and to the right. Thank you, Ariana. Make sure everybody else is awake here. How about this one? Did we have a pattern? No, they were randomly scattered. Okay, how about this? We'll be done in a second. We only got two more of these. What about this one? Do you think it has a pattern? All right, everybody take a second. I'm gonna pause the video, draw your line to the middle of this one. I bet you I'll do a pretty good job this time. All right, my guess is if I went around the room and looked at everyone's packet, this would be the closest where everyone's line would look almost exactly the same as one another. This would probably be the closest because this one's the easiest. For example, if I drew it like this, does that go through the middle of the points? No one would do it that way. No one would do it over here either. Where students would do it is, I gotta line mine up. Students would have it going, all right, I don't know why I'm saying theoretically, I saw yours. You would all have it something like that, very, very similar together. As I want you to see here, the closer the points are together, that's going to mean something to us, okay? The closest they are, the better the pattern's going to be. All right, how about this last one? Try to draw one more graph through. I'm not going to give you as much time this time. One more line through this graph, and then we're going to move on to getting the exact line where we're no longer just guessing. So best you can, try to draw a line that goes through the middle of as many points as possible. Or maybe I could say it this way. Try to draw a line that makes each point be as close to the line as possible. I'm going to add mine in. Should I do it like this? Would this make as many of the points? I'm asking this time for you to be exact. Don't just guess. I mean, don't be kind of. Don't say kind of. Does this line, the way I put it, look like it's as close to as many points as possible? No. What's the problem with my line? Too low or too high? Too low. So it needs to be somewhere, maybe in there. Does that look like it's about as in the middle as possible? Okay, so that's where we're going to put our line. So this is called a regression line. What do you call this? Regression line. Okay, here we go. So today we're going to use Desmos to get exact lines for us. So open up your Desmos graphing calculator. Mine, I have it looking a little different than normal, but that's so we can see, I can see the problem because we're going to be typing in a lot of stuff today. And then I can see the calculator at the same time. So go ahead and get yours up. Once you're on the graphing calculator, I want you to hit the plus and choose table, or you can just type in table, one or the other. So hit the little plus right here and then choose table. I haven't got yours. Table up. So get up a table and start typing in your values. Whoops, 2, 8, 12, 17, 23. Oh, I jumped ahead. I didn't say something. Over here on the table, it doesn't say it, but I want you to always do this. A lot of times on these problems, they're going to be word problems. They won't use the letters X and Y. The first column is always what letter? Is it X or Y? X. Put an X on your packet here over a number of months and put a Y over the remaining balance. This is going to be important in a moment. Okay, so I know Desmos just says X and Y automatically, but for us on our paper, I'd always do that. Okay, don't type in the commas. The commas won't work. Don't type in the commas. So if you have commas, you have to backspace those out of there. All right, I'm going to pause and give you a moment. All right, now that we have it typed in, do you see the little magnifying glass with the plus? Go ahead and click that, and it should show you those dots. Does everybody see their dots? Now, again, my screen looks a little bit smaller than yours, so it might be stretched a little bit different, but overall, it should show you the dots the same way as mine. Yes? So you're looking for the magnifying glass plus? Magnifying glass with the plus. Okay, once you press that, over here, it'll make a total sense to you after what we've done today. Do you see the button where it says X and Y, just to the left of X and Y, that has dots with a line in it? I'm going to ask a rhetorical question. That means I know you know the answer, but I'm going to ask it anyways. The rhetorical question is, what do you think the button will do that shows dots with a line going through it? It'll put our line through it. Go ahead and click that button right there. And it'll say linear regression, and it'll throw on a line that goes right between your points. Yes? Everybody's getting that? Okay, scroll down. Your equation is right below. Wow, I'm getting really weird numbers. Are you getting the same weird numbers? Okay, let's write them on our packet. It says here, the equation is y equals, are y'all getting negative 217 point? Okay, how many decimals should we round to today? 2 or 3? Do y'all want to do, or how about you want to do 1 decimal? 1 decimal today? Okay, let's do 1 decimal. 0.09. If you were in a round, does that, I forget, I'll teach y'all a rhyme. I forget what it is. 4 lower, let it rest, or 5 or greater. How's it go? They teach y'all something. I know a lot of students tell me. I forget. My question is this. Does 0.09 round to 0.0 or 0.1? 5 or more, raise the score. That's what it is. 4 or less, let it rest. It goes to 0.1. So negative 217.1 x, and then plus 7,989. Now, y'all could be getting different numbers than me if I typed in something wrong. Are y'all getting the same numbers? I didn't even ask you that. Y'all getting the exact same numbers? Great. 0.57. 57. Is that 7, 5 or more, raise the score, or is it 4 or less, let it rest?
5.
7's bigger than 5. It rounds up. So we're not going to be 0.5. We're going to be 0.6. Okay, there's our equation. I put 5, didn't I? I'm wrong. What did I need to put? 6. Thank you, Kiko. I always need someone correcting me. I don't pay enough attention sometimes. That right there is your equation. It says, what is the linear equation? That's it. So if you had to make predictions, which we will at the end of the class, that's how you would do it. Okay? Now let's go to example 2. I'm going to do 2 real fast, and then I'm going to have you try 1. This time I'm going to do it in the correct order. It says this. A counselor asks college students who had jobs how many hours they worked each week. The counselor then compared the number of hours each student worked and the student's overall grade. The table shows the data. It says if X is hours worked. I'm going to underline this time. You see where it says X is hours worked? I'm going to put an X on top of that column. You should do that first. It's going to be very important for when we make predictions at the end of the lesson. And Y is your overall grade average. I'll put Y there. What is a linear equation? No, you can put it just the way it is. You do not have to put in order. Come back to your Desmos. I'm just going to hit the refresh button. I would suggest you do the same. Let's just clear everything out. My computer's going super slow. Here we go. Let's get a new table, and I'm going to type these in. So I usually do my X's first. So start typing in your data. The things I'm going to do as I walk around the room, I typed in mine. What I'm going to check for is that you press the magnifying glass that says zoom fit, and I'm going to check to make sure your graph looks like mine. That's what your graph should look like after you press that button. Okay, I gotta say, I'm very impressed. I did not give y'all very much time, and not only did y'all zoom fit it, y'all remembered to get the line between them. You press the little button right there. It says add regression. It looks like a line going through the dots. There's my line. Are y'all getting the same equation as me? I just got to make sure I typed them in correctly because I didn't look that close. Are y'all getting the same thing? Okay, so we're going to round to 1 decimal place today. So the equation would be y equals
1.
negative 1. You can do 0.0. You don't have to do a 0.0, but I'll do it. Negative 0.0x plus.
104.
Now, would it be 104 if it's 0.95? What does that 5 do? Does it round it up or down? 5 or more, you...
No.
That's right. It'll round up to 9. And what happens when you round up a 9? It's going to become, instead of 104.95, it's going to become 100 and... 105.0. That would be my equation right there. All right, so if you, how I got that is right there. And I'll just throw this on the notes so you can see how I got that value. That's the equation there. Okay, thank you so much. Perfect. All right, great. Now that we've done that, I want you to try your first DOL. Try this one here. I'll give you a few moments. Find the equation for this set. Okay, example 3. So now what we're going to do, we've learned how to do a regression, and all of you got it perfectly. You all got it perfect. Now what we're going to do is we're going to make predictions based off of that line. So example 3. Hey, Moxie, can I get you? It says a restaurant owner experimented with different prices for the lunch special. The table shows the linear relationship between the price of the lunch specials in dollars and the number of lunch specials sold on 6 different days. So here's the price, here's the number sold. First question I have for you. The first column is always which variable, X or Y? X. Everybody put an X, please, up on top of your price. I just want you to get in the habit. That's your X. And what do we put on top of number sold then? Y. Okay, let's go to our table. I'm going to refresh my graph. And we're going to type this in. So how do I start from scratch if I've refreshed? Please don't do that. How do I start from scratch? What do I do first? Hit the plus and choose table. All right, let's type in our values. Type in all your values. I'm going to hit the zoom fit. And I'm going to hit the linear regression button. And then I'm going to wait for y'all to catch up. Okay, let's talk about rounding this equation. So today we're rounding to 1 decimal place. That means to the nearest tenth. That's my equation from the calculator. If I were to round this to 1 decimal, the first part A, says what linear equation represents. That's the equation right there. It's y equals negative. Okay, put my question for you. If it's 0.2976, 0.29, does 0.29 round to be 0.3 or does it say it's 0.2? 0.3. 5 or more, raise the score. 4 or less, let it rest. That's what you've learned. 9 is bigger than 5. If it's 5 or more, it rounds that up. So 9.3x. Now, what about over here? Plus 167 point. Okay, here's a decimal. 12158. We're talking about the just to the here. Why just a 1? Because 2 is 4 or less. 2 is 4 or less. If it's 4 or less, you let it rest. So that's our equation there. That's the equation we're going to use. Now, here's what we're going to do today. We're going to now make predictions. So look at your part B. It says, use the equation you created to predict how many lunch specials will be sold if the price is $15. Here's what I really, really want you to do. Circle up the price is $15. That's the biggest key, that you circle up the math number they give you and the unit with it. It says it's price. Look up at your table. Is price the X or the Y? X. So underneath, I want you to put X equals 15. Where did we just get X from? I heard Deja say it. I didn't ask her. Why did Deja say price was X? How did she know that? Because we put X on top of price in our table. Is everybody clear where that came from? So now, I don't type in the dollar sign. Go to your calculator now and scroll down, and as a new equation on line 2, type in X equals 15. X equals 15, like that. Everybody type in X equals 15? Now, on my zoom fit, I can't see the X value of 15. Mine, it looks like it cuts off at 12. So I need to press the minus button to zoom out. You probably will too, I'm guessing. Go ahead and zoom out one time to where you can see the new graph at X equals 15. Everybody have that? The answer is going to be where they cross each other. Click that point right there. Okay, so if x is 15, what does y represent? What is y if x is 15, meaning the price is 15? I should have said that. Sorry. If the price is 15, what do you think the 27 represents? 27 point all that? The y, the number sold. I have a question. This is a real world problem. Can you sell 27.6 or 27.7 lunches? No. So this one we're in around to nearest whole number. How many lunch specials sold? How many lunch specials could we sell?
I'm gonna say 17.
Change it to a 15. Hey, I'm going to ask this again, class. Can you sell 27.7 lunch specials? No, so this one went around to the nearest whole number. Would you say 27 or 28? Kiko's saying 28. Why 28? Which number do you look at to choose 28? You're looking at the 6. Is 6 5 or more, or is the 6 4 or less? 5 or more. So that would be the answer to this question. Make sense on how I did that? Okay. Yep, that is your answer. The lunch specials sold would be 28. All right, you've seen me do this once now, and you've seen a few different linear regressions. If you go to your next slide, I have one more that I'm going to do, and then I'm going to have you try a couple to close out the lesson, okay? So, example 4, go ahead. Example 4, let's try this problem. Let me go ahead and erase this. It says the table shows the heights and lengths of several rectangles. Part A, what is the linear regression that best fits the data set? And B, can we predict the length of a rectangle when the height is 110 inches? Here's what I want you to always do first. Let's label our variables. On the table, I told you which variable always comes first. X. So come up here on height. I want you to put an X next to height. This is X. This one's Y. Okay, label your table. Come on, Valentine. Label your table X and Y. Then go over to Desmos and let's type in our equation. Okay, I've got mine typed in. I'm going to zoom fit my data. And then I'm going to choose a regression here. All right, before I move on now, let's look at this picture over here. Remember when we were doing those graphs at the start of the lesson? I said there was one that there was no correlation, like it wasn't a very good one. Look at these dots. You see how these dots aren't looking that great? We're going to learn tomorrow that this would not be something that you can really predict very well off of because they're so far apart. This is not a very good equation. Nevertheless, I have an answer. Do you have the same answer as me? Are you seeing the same values? Okay, I'm just going to copy that answer over. If we were going to round this to one decimal place, it would be y equals, hey, stay with me, please, 0. Would we call it 0.0 or 0.1? How would we round that? 0.0 or 0.1? So is 7 5 or bigger, or is 7 4 or less? What is the 7? Is 7 bigger than 5 or less than 5? It's 5 or more, so that means it makes the 0 bigger. So it should be 0.1 x plus 24. Okay, here I have 3 9. Tell me about the 9. Is the 9 going to make the 3 become a 4, or is the 9 going to keep the 3 a 3? It's going to make that 3 a 4. Why is it going to make it bigger? 9 is, if the rule is 5 or more, you raise the score. So that's my equation right there. Now let's go to part B. On part B, it says, can you predict what the length of a rectangle with a height of 110 inches? Okay, here's what I want you to do on your paper. I just want you to get used to this. The height, circle that up of 110. Go over here to your table. What is height, X or Y? X. The reason I want you to do that is to make sure you don't make a silly mistake. Height is X. So we're going to type in height, or X equals 110. Sorry, X equals 110. So go get a new equation. Don't erase what you have. You need it. Just align to and type in X equals 110. Oh, come on, calculator. There it goes. X equals 110. And now click on where it crosses the line. That spot right there should be our solution. Did everybody get the same number as me here? Okay, so this one, here's a question. Can we have a triangle with a 32.4 inches, or do inches only come in whole numbers? Can you have a decimal of an inch? Meaning, are inches measurable, or do you count them? If it's discrete, meaning that's something you count, you can't have decimals. But if inches are something you measure, you can have decimals. Do we measure inches or do we count? What do you do with inches? Where do you see inches? On a ruler. What's a ruler used for? Measure. You can have decimals. So we'll have decimals on this one. The width, or I'm sorry, the length. The length would equal, we can have decimals. Would this be 32.3 or 32.4? 32.4 inches. That would be our answer for part B. Yes, you did. Good job. Okay, now you're ready for your two DOLs. Let me make sure I'm right. Yep, you have DOL 2 and then DOL 3. Oh, I'm sorry, I have an example 5. Go do DOL 2. All right, we're going to take a look at our last one here, example 5. The table shows the number of customers on, each hour for an online sale. Okay, I'm going to start. I cannot talk. I'm going to start with the question here. When you're given a table, what does the first column always represent? X. I know it says an X here, but I'm going to add it with color. That's an X. This is the X column. And what's the second column always? Y. I would add that to your notes if I were you. Now we want to go model this data, so let's go type it in. I'm going to hit plus, I'm choosing table, and I'm going to type in my values.
51.
Oops. Okay, I've got this typed in. I'm going to hit 2 buttons. I'm going to hit the zoom fit so I can see my dots. What do you think? Is that going to be a good equation or a bad equation? Do you see a pattern? Yeah, I see a pattern. That's going to be a good line. I'm going to now hit the add regression. So you should do that and get your equation. Okay, now let's round this value. So now that I have my equation, I'm going to say it's y equals negative 41. My first question, Ivan, this one's to you. When you look at this decimal, we're going to round starting here. Does the 0 make the 1 stay a 1? Or does the 0 make it become a 2?
No, 1.
A 1, because 0 is 4 or less. So this becomes just a 0.1 with an x plus, and now your other numbers, 337. 337 point, and this 8 does make the 2 get bigger to 3 like Deja's saying. That's our equation. Now it says, can you predict how many hours after the sale begin will result in 20 customers? I'm going to circle that up, 20 customers. 20 customers. Go to your table. Is customers the X or the Y? Customers is Y. That means 20 is Y. Does that mean my answer is Y equals 20? No. What do you do once you know it's Y equals 20? You type that in the graph. Go to your graph. Type in Y equals 20. When you type that in, click the button. Where does how many 7 point? All right. We're going to copy that over. If that's my point right there, how many hours does it? I'm going to go with the decimal. How many hours would this be? Would this be 7.7 or 7.8? This one is 4 or less, so it's 7.7. That's how many hours it would take. All right. With that, you have your last DOL.